All right, so today's notes are on polynomial long division. Our content objective is to divide polynomials using long division, and our language objective is to use the correct terminology to explain that process. So first off, polynomial long division is very similar to numerical long division. So if you learn to divide earlier in your math education using long division, this is just like that. It's just now incorporating variables as well. So the reason we're learning to this is it provides another method to find factors. So if you're ever unsure if something is factorable or if something is a factor of a polynomial, this provides a method to see if it is indeed a factor or if it is indeed factorable. So first thing we're going to do, an example, I want us to divide 6x squared plus 7x plus 2 by 2x plus 1. So we're dividing this by this. So I'm going to start by writing 2x plus 1 and then set up my long division 6x squared plus 7x plus 2. And first thing I'm going to do, I need to figure out how many 2x plus 1s can go into this. So I'm going to first try to match up. I'm always trying to match up my first term in my binomial with the front term that as I divide. So I'm going to start by multiplying 2x plus 1 by, well, this part takes some reasoning, or you can actually divide it out. So what do I need to multiply 2x by to get 6x squared? 6x squared divided by 2x would be 3x. So I'm going to multiply by 3x. So I'm going to put this on top. 3x to get 6x squared as the first term. So I'm going to multiply, I'll do this math right here. So I have 3x times 2x plus 1, and I get 6x squared plus 3x. So this is going to go here. I'm going to do minus 6x squared plus 3x, and I'm going to subtract it down. If you want to change both signs here as you do this, you can, because you need to subtract everything down. So I'm going to do 6x squared minus 6x is 0. 7x minus 3x is going to be 4x. And then the 2 just comes down. So the 2 just carries down. So now I have 0 plus 4x plus 2. So now I'm no longer worried about getting an x squared. I'm just trying to get 4x. So then, sorry, I didn't write step 2. And I'm going to subtract second equation from the first. That's what I just did. And then I'm going to repeat this process to now cancel out the 4x. So I'm going to multiply 2x plus 1. What do I need to multiply 2x by to get 4x? I need to multiply by 2 to get 4x as the first term. So when I do that, I get 2 times 2x plus 1 is going to be 4x plus 2. Now I'm going to subtract, sorry, I put the plus 2 up here. So again, these terms end up being up there, and then I have 4x plus 2 being subtracted, the whole thing. Those cancel, I'm left with nothing. So this is indeed a factor. So I subtract again. So I now know that 2x plus 1 times 3x plus 2 will give me 6x squared plus 7x plus 2. So I was able to find my two factors and see that 2x plus 1 was indeed a factor by using polynomial long division. So I want to do a quick check with you guys. I'm going to flip the page so I have plenty of space for it. But I want you guys to try this process on your own. I want you to try to divide 4x squared plus 23x minus 16 by x plus 5. and tell me, is it a factor? So tell me, is x plus 5 a factor of 4x squared plus 23x minus 16? Try on your own. I'm going to go over it now. So I'm going to set this up the same way I set the last one. All right, 4x squared plus 23x minus 16. First thing I need to multiply by is going to be 4x. So multiply by 4x. So I have 4x times x plus 5, which gives me 4x squared plus 20x. So when I do that, I have minus 4x squared minus 20x. Notice that I always put this in brackets when I do this, and this is so that I remember that I'm distributing the negative or subtracting both terms. So this ends up canceling. 23x minus negative, again, that becomes plus, so it's actually 43x. Sorry, that is 3x. That was plus here, so I copied it wrong, sorry. So it's plus 20x, so this is just 3x minus 16. And again, now I'm going to multiply by 3 times x plus 5. So I have plus 3 here so that I can cancel these terms. And I get 3x plus 15. So then I subtract 3x plus 15. Those cancel. This ends up being negative 31. So negative 16 minus 15. Negative 16 minus 15 is going to be negative 31. So I can't multiply x by anything to get negative 31. So at this point, I know it is not a factor, or the solution would be is going to be 4x plus 3 remainder negative 31. And it is not a factor because there is a remainder. So again, you can use polynomial long division to see if something is actually a factor, and sometimes it's not, because if there is a remainder, then that term is, or that polynomial is not a factor of the other polynomial. So there's one last example I want to do in case we encounter it. Last one. I want to see, is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5. So one thing you might notice is that we skip from x squared to 5, so we skip our linear term, so there's no term with just x, there's only x squared and then a constant. So one thing that's going to be really important, if there is a degree missing, in any part of the problem, put a placeholder of 0. So this is going to be really important for both parts because this is skipping our linear term and this is skipping our linear term. So we need to put 2 placeholders of 0 when we're dividing this. So to set this up, I'm going to have x squared plus 0x, which I'm going to put this, normally I'd say you don't need to write 0x, that's silly, but I'm going to put that here because we need to remember that that's the term it's holding a place of. So then I have 3x to the 4th minus 4x cubed plus 12x squared. Again, plus 0x, so our placeholder here again, so we have our 2 placeholders, plus 5. Now I'm going to multiply it out. So first thing I need to multiply by is 3x squared. So I put 3x squared up here. So I'll do the little math, the side math over here. I have 3x squared times x squared plus 0x plus 1. So it becomes 3x to the 4th plus 0x to the 3rd. So I'm still multiplying so I remember what place it's holding there, plus 3x squared. So this is going to hold the place value here as I continue on. So I subtract 3x to the fourth plus 0x cubed plus 3x squared. Subtract that out. Those cancel. I have negative 4x cubed plus 9x squared plus 0x plus 5 because those both carry down. Now I'm going to do the next one. I need to multiply by negative 4x to get that next one. So I have negative 4x times x squared plus 0x plus 1, negative 4x cubed plus 0x squared minus 4x minus 4x. So then I have minus parentheses negative 4x cubed plus 0x squared minus 4x. Subtract those down. Double negative still cancels. There's nothing to combine with the x squareds. Negative 4 becomes positive 4x, and then I carry down the 5. Keep it going. So now I need to multiply by 9 to get the next one. So again, I did these two. Now I'm going to do 9 times x squared plus 0x plus 1. So plus 9. And I have 9x squared plus 0x plus 9. And I'm subtracting the whole thing. Those cancel. Carry down the 4x. And then I subtract, I get negative 4. At this point, I can't multiply x squared by anything to get x. So therefore, there is a remainder. So x squared plus 1 is not a factor. So that's it for today. Make sure you write down any questions, comments, or concerns so we can go over them together in class.